Hello everyone, my name is Rishi and today we are going to start with an exciting series of MySQL. So welcome back to my YouTube channel Learn with Rishi, and this series is going to be very exciting as we'll be covering MySQL from basic to advanced. So make sure that you subscribe the channel and hit the bell icon to get the notifications of the next videos. So now let us start with the first module. So now let us start with our chapter, that is Introduction to MySQL and Database Systems. So before going to other technical stuffs, you can see some logos out here, that is Facebook, YouTube, Twitter, Amazon. All this single one of this company, so they handle millions of users single day. All of them running on on a databases, and most of them started with MySQL. So whatever you are building, a website or a mobile app or a backend system, at some point you will need a database, and that's exactly why we are here to learn the database system, and especially the series is going to be to learn MySQL. So in this video, we are going to cover what is database, what is a database management system, what are the types of database management system, and we will also learn why we are going to learn MySQL, what is MySQL. And so, yes, let's get started. So, you can see out here what is coming in this complete series. So, before getting started with the today's topic, we'll learn what we are going to cover throughout the series so that you will get an idea that what this series is going about. So, in the module one, we are going to start with the introduction. So this is the first video of that. What is the MySQL, how database work. And the next video will install the MySQL and understand the interface of it. Module 2 will focus on the database and table basics, like how we can create our database, how we can drop database, how we can create tables, what are the data types, what are the types of keys, what is not null default value. So all this we are going to learn in detail. Then from the next module 3 onwards, we'll learn the commands using the SQL, like the insert data, how to insert data, how to select data, how to retrieve the data, how to update the records, delete the records, like this. Fourth model will focus on filtering of the data. So if you want filter, or if you have a data, we have some part of the data we have to filter. So we have various clauses, where clause, then we have operators as and or not operators. Then we have order by limit. So these all things are going to learn in detail in the upcoming videos. Then we will move on to the next part, that is functions and aggregations. What is concat string functions? What are the maths function, aggregation functions? So these are all going to learn. Next module will be on joining and relationships. So here the concept of foreign key will be introduced. Then how we can join the two tables, how we can combine two tables, more than two tables. So joining multiple tables together. So that we are going to learn here. Then we will start with our advanced concepts such as subqueries, nested queries, then select case commands, union all. And then we have some theory about what is normalization, ER diagrams, and how we can design real world data sets. Then we will have some talk about what is performance and optimization, how we can improve the performance of a query, how we can optimize a query, what are the different techniques, methods, what is explain query, what is the analysis of the query, how we can do it, what are the tips to optimize the query. These all things we'll learn in this module. And then we'll have some discussion about what are the views, procedures, triggers, transactions, and all that stuff. And one more interesting thing is we will also solve some SQL uh, codes from the lead code SQL problems and other SQL questions which will be helpful in interviews and all. So this is a complete overview of the series, what we are going to do in this particular series. Now we'll start with our today's topic. So before answering this question, a basic thing we should know is what actually data is. What is a database and how it is managed. So basically, if I tell you what data is, so it is nothing but it is a piece of information. So your name or your age or price of a product or anything that simply is a data. That's it is a piece of information. So now this data is organized in a specific structure. So how does it is organized? So the smallest unit is known as the field, which is also known as a single piece of data, just like your name or your email address, anything. So it is a single piece of data. That is a field. Now multiple fields will form a record and multiple records will form a table. So these are all the uh, structure of the data, field, record, and table. So as you can see here, so field is our smallest unit. Multiple fields will form a record and multiple records will form a table. Okay. Now look at the diagram which is on the right side. So this diagram, I will just zoom it. Now here there is an example of an electronic bike. Okay. So you can see that there are specifications of that e-bike model. So let's say that is smart camera is there, motor power, frame battery, connectivity, onboard computer. So these are all the specifications of that bike. So these single specifications are nothing but the fields. Okay. Now we are storing these fields. So combining that fields here, we get a record. So as you can see here, combining this field, you got a record here. And multiple such records form a table and multiple such related tables form a database. So what database is now? A database actually is a collection of related tables. So why we require a database actually? So the advantages of database are very clear that we can access the information easily and we can manage the data and we can update the data. So here, all the products, so here the tables are there. So at one database, we can see that related tables are stored together. So accessing that becomes easy, managing that becomes easy. If you have to update that, it becomes easy. So that's why databases are needed. Okay. Uh, Next, what is the concept of DBMS? So basically, DBMS is nothing but database management system, and it is a software which used to control and manage the databases. Now the data is so much huge. We have to also handle the security. We have to also control the access. So for that, we have to have some software to manage the databases. So that's all taken care by the DBMS. So you can see here some logos such as MongoDB, MySQL, Oracle, Snowflake, Cassandra. So these are the examples of the DBMS software. So each of them has its own strength, but the one common thing which all of them serve is the same purpose, that is to help store and manage the data efficiently. This was all about the overview of what is data, database, and the database management system. Now we can answer these questions about what exactly is why database matters actually. So you can see here, first thing is the massive data scalability. What do you mean by massive data scalability? So think about, let's say, Instagram. So you have billions of users using the Instagram. So we have to post, reels, comments, followers list, following list, calls. There is a huge amount of data actually stored there. So So a database is designed to scale and handle this huge amount of data. So that's why we required a database so that we can handle this massive data scalability. We cannot do this simply using any spreadsheet of text files. We require a massive data for the massive data scalability. We require a database system. Next, instant query and retrieval. So whenever you go to any website, let's say Amazon, you're searching for any product. So when you search, let's say I'm searching for any product, let's say e-bike. So the result comes back in milliseconds. Yes, so that is nothing but the instant retrieval of your the database is designed such a way that it requires it returns your result of the query in under very less time. So this is possible because of databases. There is a data integrity and consistency. So what do you mean by consistency and integrity? So the best example here is about the online banking. So when you transfer the money from your account to someone else's account, so two things should happen simultaneously. One is the money should leave from your account, and the second thing is the money should arrive in the another's account. So the database, what it does is it ensures that both the things happen correctly or neither of them happen. Okay. Either both things happen or neither of them happen. So this is known as transaction. The transaction, for that the data consistency integrity is very important. Then is control and security. So of course, security is very important, access control and security. So let's say think about there is a company storing the employee records. So not everyone should see everyone's salary. So database should have some access control that managers are some data. So HR sees some data. Regular employees see only their own profile. So for each of the user, the fields or the data they see is different. So there is an access control for each of the users. And also security should be maintained by authentication, multi-factor authentication, and data encryption. These are all the things which are possible with the help of databases. Backup and recovery. So if there is any failure, so a database has a built-in backup system, mechanism to restore or recover the data from the logs. So many global companies rely on this to ensure the data is never permanently lost. So these are the five important or major points that why database actually matter. And I hope I have tried to explain you these 5 points with the help of example so that it gets clear. So now we have learned about what databases are, why it matters, etc. So now we are going to move on further slide to actually understand about DBMS. What is a database management system? So you can see here in architecture of the DBMS, you can see here are three layers. Okay. One is a external layer, one is a conceptual, and a physical level. There are the three levels, or you can say there is a three-level architecture, basically. The external level is nothing but also called as a view schema. Conceptual level is known as a logical schema, and the physical level is known as a internal schema. From the word view schema, logical schema, and internal schema, we can relate this somewhat. So let us understand what is exactly the external or the view schema, external level view schema. So this is what the end users will see. So I have a different users. So for the different user, we can create a different view. As in the previous example, previous slide, I have given an example about the manager data, employee data, HR data. All these three users will see different data. So there will be a access control. So for HR, there might be some field that only HR will going to see and not to the employee. Manager will see some different field, not to the employee. So for the different end users, different views will be built. Okay. Let's say for an admin, it sees everything. So every view will be seen by the admin. For a customer, so if it is a customer, it is not necessary. No, it is not needed that the customer can see everything. For example, you're talking about Amazon. So why should a customer see what are the inventories? Why should the customer see the other data that is not required by that user? So the customers will see is only his profile, his orders, etc. So for every end user, will create a different views. Okay. So the middle level here is conceptual level, or it is known as a logical schema. So this is basically defines what data is stored, the structure of the tables, the relationship between them. This is basically a logical blueprint of your entire database. This. So external view is what the end users will see. Conceptual level is what the data is stored. And there is physical level, which is an internal schema. We will know how the data is actually stored on a disk, whether it is in a file format, whether there are indices or there are stored blocks. So, okay. As a developer, you mostly don't deal with this level. DBMS handles it for you. Now we'll learn or we'll try to know more about this DBMS through an example. As you can see here, there are example of a smart watch system. Okay, so there are different fields here. And let's say the heart rate sensor, step counter, display, battery life, GPS. So these are nothing but the fields as we have discussed earlier. These fields will combine to form a record, and many such records will form a table, and many such related tables combine to form a database. So here we have different tables like user profile, daily metrics, location history, device hardware. So these four tables are related to each other. So a database is run. Okay. Now all these fields are captured at the physical level. So all of these fields which are there, heart rate sensor, etc. These are captured at the physical level, as the physical level is nothing but how data is actually stored. So these data are stored at a physical level. Will tell us how data is stored. Then these fields are organized into a table and records at the conceptual level. So what is a conceptual level? What data is stored? Logical schema. So so these whatever fields are there, they're organized. They will be organized in a record and a table. Okay. So this is done at a conceptual level. And when you are at the end user, so let's say you're wearing the watch. So what you see in that watch? What are heart rate sensors? You can see the time, display, battery, etc. So all these data will be say recorded. So it will be whether it's watch owner or any analyst. So it will be shown. So you will get a personalized report of that. So that will be done at the view level or the external view schema, external level. So I hope you understood about DBMS, what exactly it is. We can have a separate video explaining in detail about the DBMS system, but for now it is enough to understand exactly what is a data, database, and DBMS system. Next, we'll discuss about what are the types of DBMS. So we can divide this DBMS into basically two types. One is a relational DBMS and non-relational DBMS. What do we understand by exactly relational DBMS and non-relational DBMS? So basically, a relational database management system. So the word relational, you can understand somewhat it is related. Related data or data is in organized way, structured way. That all things come in the relational database management system. And when the data is not in an organized way or it is unstructured, it all comes in the non-relational database management. system. So basically, the relational database management system, it will organize data in a structured tables. So it has a rows, it will have a columns. Okay. So these tables are nothing but connected to each other through relationships. So for relationships means they are connected using some keys. We'll see what are these relationships keys in the next video, further videos. The examples of relational database include PostgreSQL, MySQL, Oracle. So these are all the examples of the relational databases. So basically, the RDBMS, it will make use of SQL queries to query the data, and it will follows the ACID properties to ensure reliability. Okay. So what the thing you have to understand for now is the relational database is a structured database and use SQL queries for that. While the non-relational database is not a structured database and we can't have a SQL queries for that. So it handles the unstructured database or flexible data models. It will not have a fixed table. So, so it will store the data in the form of key value storage or a document or column storage or graph based. So these are the different types. So the examples include in this type of database management systems. So we have a software such as Cassandra, MongoDB, Neo4j, etc. That is just part for your knowledge. In this series, we are going to focus on the relational database, especially the software of MySQL. Let's see about your traditional file system and relational database management system. Basically, what happens in a file system is you have a folder, store the data in files. So here you have a folder of e-commerce data. In that folder, you have created one more folder of products, customers, orders. So all these data are stored in files, folder, inside the folder files, etc. etc. So to update this data, we have to do it manually. So manual data updates. So it will lead to inconsistency across the files. Okay. Then there is a poor concurrency. So management becomes difficult. So difficulty management simultaneous file access. Weak access control, because there is a basic security at the file level, right? Inefficient searching. So we have to, if you have to search particular data, we have to search for thousands of data files because it doesn't use any indexes. Limited backup. Okay, if the data is lost in failures, so there is very limited backup. These are all the drawbacks of the file system. That's why we are using a relational database system. So we discussed already about why we are using a database system. These are all the same advantages are there. We have a special query language that is SQL. Then there is high concurrency, high security, access control is there, asset transaction, backup is there, recovery. All these are the reasons. That's why we are using a relational database management system. Let's do an overview of the RDBMS. So basically what we are going to learn in a relational database system, what it has actually. So this is a structure. Look at this database structure. So it is a database, it is having a related tables. So we have three tables here, customers, orders, and products. So each table has a row, each table has a column. Okay. Now, when you see at the uh, orders table, which has an order ID, customer ID, order date, and total. So the orders table has some column there is customer ID, which is a nothing but a primary key of customer's table, right? So that key is nothing but as a foreign key. What is in detail about foreign key we'll learn further. So it points back to the customer ID in the customer's table. Basically, it is pointing the customer ID of the customer table. And we are using it in the orders table, right? So this shows us there is some relationship between the two tables. That's why it is a relational database management system. So the customer ID column in the customer table, here it is a primary key. Primary key is nothing but it's a unique identification. So for every single row, the primary key here, it will be different for each row. So for this row, the unique identification will be 101. For this row, the unique identification will be 102. So for each row, there will be unique number assigned, that is a primary key. So no two customer will have the same customer ID. That is unique. So now look at the below table. So customer table. So let's see some terminologies here. Okay, so column. Column is also called as a field. And rows, they're also known as a tuples. These are some terminology. Fields, tuples. Okay. And it also known as a records. Yes. The column values are your actual data items. So these all values, these are the data items. John, Robert, 22 age, 21 age, these are all the data items which are known as the column values or data items. Okay. And the first column ID, this is nothing but a primary key because it is uniquely identified. Then, what are the key components in the RDBMS? Majorly, there are four components. One is tables. Tables are nothing but a structured data stored in the rows and columns. Relationships, there is a connection between the tables using the keys, primary key, foreign key. SQL queries, if you want to access the data, we need some language. That is nothing but SQL, structured query language. And ACID compliance ensures reliable transactions. I've given you an example of the bank transaction and about the massive data Instagram example I have given. ACID compliance is atomic, consistent, isolated, and durable. So these are all the key components. We'll further learn more in detail about this. What are the different operations basically you have in RDBMS? In short, we can create a table, create a database using DDL commands. Then we can read using DQL commands. Can update using DML commands. Delete. Can perform operations, join operations. Can perform indexing. So these are more advanced topics. We'll cover in depth in the later in the series. This is just an overview of RDBMS. And actually about MySQL, we learn how we can query this all things through SQL language. Let us move further now. Now, two most important definitions here are SQL and MySQL. What is SQL? What is MySQL? Basically, SQL is nothing but a structured query language. It is a database language. It is a database language which will be using to query and operate a database system. It is just as a programming language used for managing the relational database, for updating it, manipulating it. Whether you have to insert the data, update, delete, anything you have to do throughout it for the data. For that, we are going to use a language known as a SQL. Then what is a MySQL? MySQL is a software which will use a SQL language. Basically, SQL is a language. Software we are going to use is a MySQL. So it is a database management system, especially a relational database management system that you can install in a computer or in a server. You use SQL as its language. And so when you want to talk to MySQL, you write a SQL series, SQL queries. MySQL read those queries and it will execute them and return you the result. So simply, SQL is a language. MySQL is a software that speaks that language. This was the wrap on video 1. So let's recap what we have learned throughout this video. So we started with what data is, what are the fields, records, what is a table, what is a database. We understood why we require data, why actually database matter for the scalability or storing the massive data, and speed, then the security, consistency, backup, recovery. We also learned about what is database management system, why we required database management system. Then we discuss about the two types, relational database and non-relational database. And we also discuss why we are focusing on the relational database management system. What is the difference between the file system and the relational database management system? What is the difference between the SQL and MySQL? These are we have learned. Okay. So what we are going to learn in the next video. Next video will be all about installing the MySQL software so that we can start with learning the SQL language. So if you like this video, subscribe the channel and click on the bell icon so you get a notification of the further new videos. Thank you. We'll see you in the next video. Keep learning.